Okay, Mersenne, is it? I don't know. Mersenne primes are prime numbers that can be written in the form 2 to the power of n minus 1, where n is a whole number. So really, it's just some prime numbers can be written like that. It doesn't really matter about that first word. For example, 3 can be written as 2 squared minus 1. Prove that 2 to the power of 9 minus 1 is not a prime, a Mersenne prime. So let's have a look at that. 2 to the power of 9 minus 1, what does that equal? Well, 2 to the power of the 9, just on the calculator, minus 1 equals 511. So we need to prove that that is not prime. Now, I've recently discovered that you can do the prime factorisation on your calculator. So I'm going to let you into a little secret. So here is your fact button. See it? Now, if you press, bear with me, it takes me a while, 511, press equals, and then hit your fact button, so shift, and then that will make it into its prime factor format. That will save you some work, because normally what I would do, I'd be like, right, let's think what numbers go in to 511 to think about a factor tree. It's a calculator paper, so we might as well use this little cheat here. I don't think you can. I'll try it again. I'm sure I've tried it before. You can't just press 511 and then hit. Oh, that's not the fact button. Try it again. You can't hit 511 and then put shift fact. It doesn't know it that way. So it doesn't. If you just press shift and that, it doesn't do anything. So you press the equals button and you just press shift fact, and it splits it into the prime numbers. So proving it is 5. Oh, not 5. It was 7. Sorry, 7 and 73. So 511, just write a little sentence, isn't prime. It's 7 times 73, and primes only have 2 factors. So we know it's 1 times 511 and 7 times 73. This one's got 4 factors. So you could write a sentence, as long as you're really clear, write a sentence to do with it, and you're away. Right then, part B then, it says there are, I'm going to call them the n primes. There are the n primes when n is 5 and when n is 7, and then, is it Anna? Anna says that the ratio of the indices is 5 to 7. So when n is 5 and n is 7, the ratio of the indices is 5 to 7. This means that the ratio of the n primes is 5 to 7. Show that Anna is wrong. So we're going to sub in these values when n is 5 and when n is 7 into that equation that we were given. We were told that it was 2 to the 9. No, it wasn't 2 to the 9. What am I talking about? We were told it was 2 to the power of n minus 1. So when n is 5, let's see what that value is. 2 to the power of 5. Make sure the minus goes down there. Minus 1 is 31. And when n is 7, we get 2 to the power of 7, 2 to the power of 7, and then take off 1 from it, we get 127. So obviously when the indices, when we put it in that, so what we're saying is when we put 2 to the power of 5 minus 1 and 2 to the power of 7 minus 1, the indices, that's that bit there, are in the ratio 5 to 7, which is true. This means that the ratio of the actual n primes, so these are the Mersenne primes, that's in the ratio of 5 to 7. So 31 to 127. Well, that's what they're in the ratio of, 31 to 127. And is that 5 to 7? Well, she tells us that it's wrong, so we've just got to prove that there's no relationship between that and that. So we just know it's 31 to 127, which is not 5 to 7. Because if we think about, you could prove it, you could do 31 divided by 5, that's 6.2, so that's times by 6.2, or in this case divided by 6.2, and 127 divided by 7 is 18. That's divided by 18.14. So you can see I'm probably going into a little bit more detail than needs to be, but as long as you're saying what the answer is 31 to 127. No, it's 31 to 127, which is not 5 to 7. That should be good for all the marks.